So this review video is about solving quadratics, and there are 4 methods we have learned as far as how to solve quadratics go. We learned how to solve by factoring, we learned how to solve by square rooting, how to solve by completing the square, and how to solve using the quadratic formula. And so that's what we're going to talk about today. We're also going to talk about some of the other important things you need to know in the process of solving quadratics. So you need to be able to simplify radicals, and you need to be able to work with imaginary solutions. And so one of the things we learned was that I, the imaginary unit, equals the square root of -1. And then the last thing on this video is talking about how do we know which method is a viable method when we look at a quadratic and we're not told what to do. And so that's what we're going to work on then. So we're going to start out with factoring. So whenever we have a solve by factoring question, the first thing that we want to do is make sure that we get the entire equation on the same side set equal to 0. So the first thing I'm going to do is move that -4 by adding 4 to both sides. And once I do that, I know that I have my entire quadratic over here, and that's the part that I'm trying to factor. And so you might have different methods for factoring, but the method we talked about in class was using our box organizer. And when we do that, we want to always put the A term here and the C term here. And so we're trying to figure out what options do we have as far as values that can go here and here to multiply to give us 5x squared, and then 2 numbers that go here and here to multiply to give us 4. And then the resulting numbers here and here will have to add to give us our B term. So that will have to add to give us 21x. So because 5 is prime, the only option that we have as far as multiplying to get 5x squared is a 5x and an x. And so I'm going to write 5x and x, and then I'm going to say, okay, well, I have a couple options as far as what multiplies to give me 4. 2 times 2 equals 4, and 1 times 4 equals 4. So I'm going to try those 2 options out. I know that if I put 1 here and 4 here, I'm going to get, let's see, I think that worked on the first try. That's not normal. Usually you might have to try more than once. But if I put those there, 5x times 4 should give me 20x, and 1 times x will give me 1x, and that will add to give me 21x. Now usually that's not so normal, right? We might have to try more than once. We might have started with 2 and 2, and we'd get 2x, and then 2 times 5x would be 10x, and we would know that 10x and 2x can't add to make 21, and so we'd keep trying our solutions. And remembering that positioning matters, so if we had started with 1 here and 4 here, that just because that position didn't work doesn't mean that we can't flip them for it to work. So you're going to try it out, until it works, and I do believe that this will work. So I get my factors, and my factors come from here, which is 5x plus 1, and from here, which is x plus 4. And I know that that equals 0, and because of the 0 product property, I know that if the product of these 2 things equals 0, that one or both of them could equal 0 and still have the equation be true. So it's true if 5x plus 1 equals 0, or it's true if it's x plus 4 equals 0. So we can split them. We can only do that when the equation is equal to 0. Once we do that, we're going to solve the regular way that we've been doing for a while, and we get x equals -1/5 as one of our answers, and x equals -4 as our other. So solving by factoring, you're going to factor, you're going to set it equal to 0, you're going to factor, split it up, and solve. Next we have solving by taking the square roots, and this is really only a good candidate when we don't have a b term. And what I mean by that is there's no term in here that has just regular r. We have a term with r squared, and then we have constants, but we don't have 5r or 3r or anything like that. And so that's how we know that solving by taking square roots is a good method here. So when I'm solving by square rooting, I want to isolate the variable, and so I'm just going to start peeling off layers. I'm going to start by adding 2 to both sides. And then I want to peel that 4 off, so I'm going to divide both sides by 4. And so I get r squared equals 9. And then I'm going to peel off that squared by undoing it with a square root. Because a square root will undo the square. And whenever we do that, we always have to make sure we remember that if we're wondering what squared gives us 9, that there are 2 answers here. There's a positive and a negative. Because 3 times 3 is 9, but also negative 3 times negative 3 is 9. And so those are our 2 answers, 3 and negative 3. Okay, so next we have solve by completing the square. We know that something is a good candidate for completing the square when we have an a value of 1 and we have an even b. And if we have those 2 things, completing the square is a good method. So I'm going to start by getting this part by itself. I'm going to subtract the 80. And the reason that I want to do that is because I want to find out what I can put after 18 to make this a perfect square trinomial. And so whatever I find out that number to be, I'm going to add it to both sides so that we have it in both places. So I want to fill in that blank. And the way that I figure out what value that is I take our b value, which I almost forgot my n there, and I take b, which is 18, and I divide it by 2, and then I square it. So 18 divided by 2 is 9, and then 9 squared is 81. And so I'm going to add 81 to both sides. And that's the way that I'll know that I have now created a perfect square trinomial. Now, what is the benefit of having a perfect square trinomial is that now we can write that trinomial as something squared. And I'm going to simplify on the right here. Negative 85 plus 81 is negative 4. And so I can write it as n plus some number or n minus some number. And the way that I know what number that is by looking at what that b over 2 was. B was 18 divided by 2 was 9. And so I know that that factors to be n plus 9 times n plus 9, which we can write as n plus 9 squared. The great thing about that is now I can finish solving by square rooting. So I can take the square root of both sides to undo that square. And so I get n plus 9 on the left. I make sure I remember my plus or minus when I take the square root of both sides, and I have the square root of negative 4 on the right. Now, the square root of a negative is going to give us an imaginary number, so we can write it as the square root of negative 1 times the square root of 4, because the square root of negative 1 is I, and the square root of 4 is 2. I'm going to bring this n plus 9 down. So I get plus or minus 2i. And then the very last thing I'm going to do is subtract 9 from both sides. And we put that in the front here so that it is in standard form. And we have 2 answers, negative 9 plus 2i and negative 9 minus 2i, which we can leave as negative 9 plus or minus 2i. And so solving by completing the square was a really good method here because we had imaginary solutions. So the first thing that we want to do if we're using the quadratic formula is get the whole thing set equal to 0, just like we would if we were factoring. So the first thing I'm going to do is start to move everything over. And so I'm going to add 12k to both sides so that I can have the whole thing set equal to 0. And so the next thing I'm going to do is I'm going to identify my A, my B, and my C. And it doesn't matter what order each of these terms are in. The A is always going to be the coefficient on the x squared. The B is always going to be the coefficient on the x. And then the c is always going to be the number that is a constant by itself. So I'm going to identify that my a is 5, my b is 2, and my c is negative 13. And that way I can substitute in to the quadratic formula, which we have to know. And that is going to be x equals, well, since we don't have x, we have k. It'll be k equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And when we do that, we're going to have negative b is 2, so that's negative 2, plus or minus the square root. Every time we square something, we put it in parentheses like that. That way it takes care of if there's a negative being squared. And then minus 4 times a times c, and the whole thing is over 2a, and a is 5. So next we just have to simplify very carefully, and this is why I'm not the biggest fan of the quadratic formula. I think the other methods are better if you can use them, because simplifying is a place that many students make mistakes. So I get 4, the negative times the negative gives me a positive, plus 260, all divided by 10. So that gives me the square root of 264, all divided by 10. And keep in mind that we can't divide these out and simplify them unless we're also going to do these. And we can't do these because this one's inside and this is outside. So we're pretty much locked in right now where we're at, unless we can simplify 264. And there's a perfect square that multiplies into 264. So I'm going to think about what perfect square might multiply in. I might try 9, or I might try 4. And 4 does work. So I could rewrite that as the square root of 4 times the square root of 66. And that will help me because now I have negative 2 plus or minus 2 root 66. And now I can simplify negative 2 over 10 and positive 2 over 10. We can cancel out a 2 and simplify that to be negative 1 plus or minus 1 root 66 all over 5. And 66 does not simplify any further. There are no perfect squares in there. And so we are good to go, leaving our answer like that. Now, how do we simplify if we have something like this? We know it's not in simplest form because we have a square root in the denominator. We can't have any radicals in the denominator. So the best way to clear that out is to multiply by the square root of 10 on the bottom. And if we do that to the bottom, we have to do it to the top as well. So that will give us square root of 90 divided by square root of 10 times square root of 10 is 10, because that's the square root of 100. So you can jump straight to it being over 10 if you are good with that. And the reason why this is okay is because anything divided by itself is 1. So we're not doing anything different than multiplying by 1. So we're okay there. And then we also can continue to simplify because the square root of 90 would be the square root of 9 times the square root of 10, which is 3 root 10 over 10. And that's our answer. We can't simplify any further. We cannot cancel these 10s because one's the square root of 10 and one is 10, and those are not equal. Now, what if we have a similar situation, but instead we have something plus a root in the denominator? Well, in that case, we are going to multiply by the same thing on the top and the bottom, but instead of multiplying by the exact denominator, we're going to multiply by the conjugate. And the conjugate just changes the sign. So instead of 2 minus square root of 2, it becomes 2 plus the square root of 2. And the reason why this works is because it's going to cancel the radicals in the denominator. So on the top, I'm going to make sure I distribute that 7. So 7 times 2 is 14. And then 7 times root 2 is just 7 root 2. And then on the bottom, I have to make sure that I FOIL. So I'm going to multiply 2 times 2 is 4. 2 times root 2 is 2 root 2. Negative 2 times 2 is negative 2 root 2. And then negative root 2 times root 2 is going to become negative square root of 4, which we know is 2. And so we're going to simplify. The good news here is that 2 root 2 minus 2 root 2 is 0. So that leaves us with 4 minus, and the square root of 4 is 2. And so we can simplify just a little more. And we have gotten rid of the radicals in the denominator, so we can stop there. We have simplified. Now, how do we simplify with complex numbers and imaginary numbers? The key is to think about it like it's a variable. You are just going to combine like terms in the same method. So here I have negative 4, and then it says minus 6, and minus a negative, which is plus 2i. And then I still have plus 7i. And so what I want to do now is find my like terms. 2i and 7i combine to give me 9i. And negative 4 minus 6 is negative 10. So just combining like terms, making sure I'm being really careful with distributing the subtraction symbol. I'm subtracting the 6, but I'm subtracting the negative 2i. Okay, so in this case, we are squaring a binomial, which again, squaring means multiplying by itself. So we get that. And we are going to make sure we distribute the negative 4 to both negative 4 and 6i. So we get positive 16. Negative 4 times 6i is negative 24i. We have another negative 24i from 6i times negative 4. And then 6i times 6i, which is 36i squared. And then we know that we can combine like terms, and we get negative 48i. And then instead of I squared, we can replace that. We know that I equals the square root of negative 1. So if we want to know what I squared is, I could square both of those to find out that I squared is just negative 1. So whenever we see I squared, we can replace it with negative 1. So that gives us 16 minus 48i minus 36. And so we have negative 20 minus 48i as our most simple and correct answer. This question asks us how many and what type of solutions does an equation have? Anytime we're talking about how many solutions and what kind they are, we're talking about the discriminant, which is the part in the quadratic formula that is under the square root. So it is this part right here. So it's b squared minus 4ac. Now, the thing is, we can't use that until our equation is written in standard form. So I'm going to subtract 2r, and I'm going to add 1 so that it's set equal to 0. Now I know what my a, b, and c are. So my b is negative 2, my a is 1, my c is 1, and so I get negative 2 squared is 4, minus 4 is 0. Now, if I think about this being 0, that would become this plus 0, with negative b plus 0, and negative b minus 0. But negative b plus 0 and negative b minus 0 are the same, so that means that I only have one real solution because the discriminant is 0. Anytime the discriminant is 0, we have one real solution. If the discriminant was positive, then we would get two solutions because we'd have negative b plus some number and negative b minus some number, and so they would give us different answers instead of give us two possible answers. And so that would be two real solutions. And then if the discriminant was negative, we'd have a negative under a square root, which means we would have imaginary solutions. So that's 2 imaginary. So you have these 3 options. If the discriminant is 0, you have 1 real solution. If the discriminant is positive, you have 2 real solutions. And if the discriminant is negative, you have 2 imaginary solutions. Okay, our last topic is how to choose a viable method. When you look at a quadratic, you have several choices. You can complete the square, you can factor, you can solve by square rooting, or you can use the quadratic formula. But not every method will work every time. The only method that is a viable method every time is the quadratic formula. However, I don't think that's the easiest method because there's a lot of opportunities for mistakes. There's also a lot of simplifying that has to happen that doesn't always have to happen if you use a different method. So it's not my favorite method. I think it's the slowest. So in order to start thinking about what method will work, the first thing I want to do is go ahead and replace the equations by moving everything over to one side. And that's just going to make it a little easier to identify a method. So I'm going to have, and I believe that that's b squared minus 36, not minus 3b. Then we have r squared minus 2r plus 1. And we have 3v squared minus 5v minus 2. 3p squared plus 2p plus 1 equals 0. And then we have 2b squared minus 32 equals 0. 2x squared plus 8x plus 2 equals 0. And p squared minus 18p. And if we add 9 to both sides, we get minus 62 equals 0. Okay, so now when I'm looking at these, the first thing I'm looking for is if there's a greatest common factor that I can divide out before I do anything more. And in this case, in this first one, there is. We can divide everything by 2. And so that gives us 3x squared plus 5x minus 2 equals 0. And I think that that really helps because it makes the numbers smaller and easier to look at. So when I look at that one, I would say that you are asking yourself, can it factor, can I solve by square rooting, or can I complete the square? And I know I cannot complete the square efficiently because this a value is not 1. So then I ask myself, can I factor or can I solve by square rooting? And I can't solve by square rooting because I have a b value. I have a b term right here. So my only option is to factor, and if I can't factor, then I'm going to have to use the quadratic formula. So I believe that this one does factor, and if you did the Bax method, I think you would get this, and yes. And so this one does factor, so it's a good method. So factoring was viable for this one. I always think it's better to try factoring, and then if you don't have success in a few minutes, to then switch to the quadratic formula. Now, the second one that I'm looking at, we have b squared minus 36 plus 6, which is b squared minus 30 equals 0. And I think that this one is a very good candidate for solving by square rooting because we don't have a b term right here. We don't have something that says plus 3b or plus 5b or minus 6b. We just have the b squared term and a constant. And so that's going to allow us to actually take that and say, oh, well, b squared equals 30, and so b equals plus or minus the square root of 30. And so from that, I'm going to say solve by square root. Now this next one looks like a good option for factoring potentially. It also is a good option for completing the square, because for completing the square, we're looking for something that has an a value of 1 and an even b value, and we do have that. But as I'm looking at this, hopefully you're recognizing that that one should factor very nicely, and it does factor. And so we get r equals 1. And so factoring is a great method there. Now looking at the next one, 3v squared minus 5v minus 2. I know that I can't solve by square rooting because I have this b term, negative 5v. I can't solve by completing the square because I don't have an a value of 1. So factoring or quadratic formula are my only two options. And I do think this one might factor. It's very similar to this other one that we have right here. I think it just switches the signs, right? 3v and v, and we're going to need that to be a negative here and a positive here. So I think it's exactly the same. It will work out the same way. It will factor just like the other one, just with a slight tweak. And so we wouldn't be done solving there. We'd have to solve to get v equals negative 1/3 and v equals 2. Just like up here, we would have had to get x equals positive 1/3 and x equals negative 2. And then looking at our next one here, I'm looking at that one and thinking I can't complete the square because I don't have an a value of 1. I can't solve by square rooting because I have this b term. So factoring looks like my only option, but as I'm looking at that, I don't think it's going to factor because the only options that multiply to give us 1 are 1 and 1. And 1 times 3 is going to give us 3. 1 times 1 is going to give us 1. I can't see how 3 and 1 will make 2 without there being a negative, but because we have both positives, that's not going to work. So for those reasons, I think factoring won't work. You're welcome to always try it, see if it will work. But if not, then it becomes time. We already said we couldn't square root it. We already said we couldn't complete the square. So really the best option here is going to be to use the quadratic formula. So I start to plug it in. B squared minus 4 times a times c all over 2 times a. And I'm not going to continue simplifying it, but hopefully you're noticing that the reason why this wasn't working another method was because this is going to be an imaginary answer, because we're going to get 4 minus 12. We're going to get a negative under the square root. So we're going to have i's in our answer. Okay, now looking at this one, I'm thinking that square rooting is a good option, just like this one, because we don't have that b term. So it should be pretty simple as far as solving goes to add 32 to the other side, divide by 2, and then square root both sides, making sure not to forget about the plus or the minus. But square rooting will definitely work for this one. Okay, looking at the next one we have, I'm just going to move this up a little bit. We have a common factor, right? Before we do anything else, we can divide everything by 2. So that will make all of these numbers smaller and give us a better eye for where we're at with this one. So looking at it, it's not an option to factor because there's just no way to add to 4 when multiplying to get 1. So factoring won't work. We can't solve by square rooting because we have this b term. And so maybe we could complete the square because we have an a value of 1. We also have a even b value. So completing the square is going to be a great option. that means we are moving the 1 over to the other side, and then asking ourselves, what would complete this square? And we're going to say 4 divided by 2 is 2. 2 squared is 4, so I'm going to add 4 to both sides. And then I can rewrite this as x plus 2 squared equals 3. And then I can take the square root of both sides. I get x plus 2 equals plus or minus square root 3. So that's negative 2 plus or minus square root of 3. And so completing the square was a great method there. And then looking at this next one, same idea actually. I have an a value of 1. I have an even b value. So I'm thinking completing the square will be a good method. It also is possible that this will factor, but off the top of my head, I'm having a hard time thinking of what multiplies into 62. And so for me, I think I'm going to go for completing the square because I know that that method will be good. And so because of that, I am going to start by moving that 62 to the other side. And we want to add something to both sides that will make that a perfect square. So negative 18 divided by 2 is negative 9. 9 squared is 81. And so that will become p minus 9 squared. And that will become 143. And then we finished out by square rooting both sides, making sure we remember our plus or minus. And because 143 doesn't simplify any, we're left with our answer there. So completing the square was great for this one as well. So notice how out of these 8 problems, I only did the quadratic formula once. Now you might do it more than once, but I do think it's a method that, although it's a catch-all method, it will work in any situation. There are far more efficient ways to go about it. And so that's why it's so important that you know how to factor and complete the square and solve by square rooting. Great. Good luck with your studying.